A logic chip executes several billion computing steps per second. Since most steps calculate with numbers which are the result of earlier calculations, all computations have to be coordinated with regard to timing. The chip is therefore clocked. Start and finish of all calculations are storage elements called registers or latches, as well as inputs and outputs of the chip. Every 200 picoseconds, a clock signal reaches all the registers and initiates the start of the calculations. At the end of a clock cycle, 200 picoseconds later, all calculations have to be completed, which means that the results have to be stored in the registers. In the next clock cycle, calculations continue with these results. 200 picoseconds are the 5 billionth part of a second. This equals a clock frequency of 5 gigahertz. That is approximately the speed of modern high-end processors. If long distances on the chip have to be bridged, for example 1 millimeter, or an interim result is needed at many other places, 200 picoseconds are not a lot of time. In this case, charging or discharging the wires and inputs of the transistors might take a lot more time. By choosing the optimal size of transistors and by inserting repeaters, so-called buffers, the signal flow can be accelerated. However, it is not easy to insert the buffers at the optimal places. You can later try it yourself in a game. Another problem occurs with very complicated calculations. If a signal passes many logical elements, for example several and or elements, alternately, as we can see here, this often requires more than the available time. The following film will show you how logical structures can be optimized in such a way that all the signals arrive on time.